Welcome back to PV Online. Today we're going to take a look at conservation of momentum and exactly what that means. And essentially for our purposes, however much momentum you have before some interaction is going to equal the total momentum after the interaction. So let's take a look at this very first example, which is going to be similar to your homework. We have Rob is drifting on a skateboard and suddenly jumps off. And so in this table, you can see that before the collision, he had 140 kilogram meters per second of a momentum. The skateboard had 10 kilogram meters per second. After the, we're going to consider an explosion anytime there's been a big change. So afterwards, we want to find out how much Rob has. We see that the skateboard has 50 kilograms meters per second, and we want to find out the total both before and after. Now, what you're going to find with these problems is very often it's not going to be necessary to answer 1 before 2 before 3. As a matter of fact, in this case, since I know the initial momentum of both Rob and the skateboard, I would just find the total momentum right now. And all we need to do is realize that the total momentum for our problem is going to equal the momentum, the initial momentum of Rob, plus the initial momentum of the skateboard. So we can do that in our head. What's 140 plus 10? That will be 150 kilogram meters per second. The law of conservation of momentum simply says that the initial momentum is going to equal the final momentum. What that means is that the total momentum before the explosion is going to equal the total momentum after the explosion. And so that's going to give me a total momentum after the explosion of 150 kilograms meters per second. The total momentum in our systems will always be equal. Okay, so now we have our last one, and that's going to be, let's find out what is the momentum of Rob after the explosion. All right, I'm going to scroll this up a little bit. And using this relationship right here, that the total momentum is simply going to be the momentum of both objects, we're going to use that concept right here. Now, we're looking at afterwards, so we're looking at the final, but the total momentum is still going to be simply the sum of them. So I'm going to have the final momentum of Rob plus the final momentum of the skateboard. Well, we know the total momentum is 150. I'm looking for the final momentum of Rob plus the final momentum of the skateboard, which was 50. So 150 minus 50 is going to give me 100 kilograms meters per second. And just look, we add those two up, it equals the total. The total before and after has to be the same. All right, let's take a look at a little more interesting one. And this time, we have a 1,250 kilogram car is stopped at a red light, or stopped at a traffic light, and a 3,000 kilogram truck is moving at 8 meters per second. Unfortunately, is going to hit our car. So let's go ahead and write down the information that we were given. I'm going to call the car M1. So M1 is going to have a value of 1,250. And since the car is at rest, we know that the initial velocity of car 1 is 0. I'm going to call the truck M2. So M2 is going to have a value of 3,000 kilograms. And we know that the initial velocity of the truck, so I'm going to call it V2I, has a value of 8 meters per second. So let's take a look at the before. The before is pretty straightforward. The initial momentum of the truck, so I'm going to call that 1, is simply going to be mass times velocity. So if we take 1,250 times 0, that means the initial momentum of the car is going to be 0. I'm going to do the same thing with the truck, so I'm going to call that P2 initial, and that's going to be 3,000, that's my mass, times the velocity, which is 8. So we multiply those two together, and we know that's going to be 24,000 kilograms meters per second. Well, to find the total, what do? we add the two. We add the momentum of the car. So the total momentum is simply going to be the momentum of 1 plus momentum of 2. So I know this is going to be 24,000 kilograms meters per second. All right, so now what's going to happen in this case is we're going to say that they collide and stick together. And since they collide and stick together, that means this is going to be an inelastic collision. And with an inelastic collision, that means they're going to have the same final velocity. So I'm going to call this M1 V1 initial plus M2 V2 initial equals, since they both have the same velocities, I can just add up their masses times the final velocity. All right, let's go. I'm going to need a little more room here. So the mass of the car was 1250, but the initial velocity is 0. So any number that I multiply times 0 is going to be 0, so I can just delete that term. So now I'm just concerned with the momentum of the truck. So I'll take 3,000 times V2 initial, which we said was 8, equals the mass of the car. Remember, they're stuck together now, so that's 1250, plus the mass of the truck, which was 3,000, times the final velocity. Now remember, the final velocity for both of them will be the same. So I've got 24,000 equals, I'm going to add those two together, that's giving me 4,250 times V final. Now to find V final, what do? I divide both sides by 4,250, and that's going to give me a final velocity of 5.65 meters per second. Both the car and the truck are going to be moving at 5.65 meters per second. So let's come down here, and I want to find the final momentum of the car. So the final momentum of the car is going to be the mass of the car, which we said was 1,250. The final velocity we just found is 5.65 equals, and that's going to give me about 7,060. And that will be kilogram meters per second. I need to do the same thing for the truck. So that's the final, equals the mass of the truck, which is 3,000, times the final velocity, and they're going the same speed because they're stuck together. And that gives me, let's see, around 16,940 kilogram meters per second. So let's go back and fill this into our table up here. So the mass, or the momentum of the car was 7,060 kilogram meters per second. The momentum of the truck is 16,950. So do you see how the momentum of the truck went down? But if I add these two, I'm going to get 24,010, but let's just round it to 24,000. We're going to have a little rounding stuff going on. So look what happened. My total momentum stayed exactly the same. It was equal. That means the change in the total momentum is 0. Now you might end up getting something like 10, but we're using numbers that are so big, don't worry about it. That's essentially 0. Now look at what happened with the change in the car. The car increased in momentum by a positive 7,060. And the truck actually lost momentum, and that momentum it lost went into the car. Now when you get this, I think you get something like negative 7,050, but just for the heck of it, let's just round it to negative 7,060. And look what happens here. The momentum gained by the car is the momentum that was lost by the truck. All right, you should be able to do this assignment. We'll see you next time.